Welcome to lecture 11. This one is on Pascal's triangle. Well, it's actually on Pascal because I'm going to not just deal with the triangle, I'll add a few other ideas. And this is also an entry in my book, the Beyond Science. So Pascal was involved in various things. He was in physics, he was involved with fluid mechanics, and he was also a mathematician. He used cycloids to calculate the volume of solids. I'll talk about that. And he's famous for his Pascal triangle, which probably, unless you do A-level mathematics, you may not come across that. But it's one of his famous sort of inventions, discoveries. So let's look at Pascal, and we'll see a few interesting things about his name. So Pascal, his first name is Blaise, which is spelled B-L-A-I-S-E, Pascal. And you notice straight away that both names have got 6 letters. Okay? Now, 6 equals 52 in placement value. Okay? And he was involved with fluid mechanics, and if we take the words fluid. We take the word fluid we take fluid pressure. That's what he was working on, and we take fluid pressure, and we work out the placement value, and we work out the large value. In actual fact, what we're going to work out is the placement value plus the large value, which is the whole value. Those two together give me the whole value, and that comes to 1,194. Those can't remember what the large value was. F is 6, and the word 6 is 52. So I was going to put up here that 6 is 52, and that equals fluid, because fluid is 6 plus 12 plus 21 plus 9 plus 4. Okay? And that's 18, 39, 48, 52. It's also 52. So fluid and 6, just connection to the number of letters in his in his name. So we have the whole value, these two together, of fluid pressure to be 1,194. And then if we were to take Blaise Pascal, his full name, I just make it short, BP, that's not British Petroleum, Blaise Pascal, and we're going to work out the placement value is 100, the large value is 742, and we're going to work out the normal value, which is 352. We add those together, we get the same as that, and that I call, because the placement value and the large value is the whole value, so I put W first, and then N for the normal value, so I call it the WNV value. Normal value, to remind again for that, is when you take, this is really used in Hebrew and in Greek, where you take the decimal values where B will be 2, you get up to J is 10, then the K is 11, K is 20, and L will be 30, and then you go up to S, which comes 100, and T will be 200. That's the normal value, normal for Hebrew and Greek, but not for English. But that gives us now a connection between using these three, what I call vibrational aspects of his name, or the energies of his name, and that gives a relationship between what he works in, fluid pressure, and his name. So now, yes, I missed out that one. Pascal is 16 plus 1 plus 19 plus 3 plus 1 plus 12, plus 12, and that's 20, 36, 39, 40, 52. So that is now connected to fluid again, and the number letters in his name. Okay, one more with that fluid before we move on. So we have another connection. We have fluid with the normal value of 6 plus 30, L is 30, U is 300, I is 9, and D is 4. Add that together, get 330, 349, and that's the normal value, decimal values. And we take Blaze, and we use the large value. B is 2, and 2 is 58. L is 12, and 12 is 87. A is 1, and 1 is 34. I is 9, and 9 is 42. S is 19, 19 is 86. And E is 5, which is 42. And I add those together, I get 15, 19, 21, 27, 28, 29. Carry 2. I've got 5 plus 8 is 13, 16, 20, 28, 32, 33, 34. So in the large value, I've got 349 for Blaze, and fluid in the normal value is 349. So we have a match, we have a connection, an energy connection, something which they vibrate with. He obviously is interested in fluids, it's inside his makeup. That is the most perplexing aspect of what I work in this whole idea of gematria. It's quite mind-baffling, but it seems to be, this is the reality, because I've got so many names, and it works with, if I told you how many books I'm in the middle of trying to write, it just, I'm writing a book on artists and showing how they relate to, like Leonardo da Vinci is related to the Mona Lisa, and I've got books named people's authors that are related to the books that they write. So this is something so you can look at yourself and say, I have a name, and what is my name? What is my name connected to? How do I work? I have at least two people, just normal common people like you and myself. Well, none of us are common, right? We're all unique and special. But these two people, one was working in 3D filming, photography, making films in 3D, and the other one is just a grocery manager, right? And their names connect to the professions in which they work in. So it would work for all of us. You can try it at home. You know your name, and you can see any connection to what your career is or what your hobbies are maybe. Okay, now I said before that Blaze worked in the field of mathematics as well. He uses cycloids. Cycloids are, if you take a wheel, circle, and you make a point on it, the locus that that this point will trace as the wheel moves around, like a bicycle wheel, will be something like this. Now, that's a cycloid. How he used that to calculate the volumes of solids, I do not know. I've not actually looked into how he did that, because normally it's done by integration, three-dimensional integration we would have to use to find solids. Let me rub that off as well. But he was into cycloids, and Blaze has a large value of 349, which we've just done. He has a normal value of 147, and he has a normal inner value of 384. And adding those together is 880. And I call that the LNNIV value. I've got nothing better to call that. It'll have to do. but it's using the large value, the normal value, and the normal inner value. The normal inner value, remember I use the normal value, so L is 30, 30 equals 100 as a word, the word 30. So it's really similar to the large value, but the baseline is not the placement value, the baseline is the normal value. So using these values, S is 100 in the normal value, and it equals 108, the word 100, 100, two words actually, 100 equals 108. And add those together, you have to do these are the digits. They're the same as the large values because they're units. So that gives me 880. Let me write that off. And if I take cycloid and I work out the placement value, which is 71, and I work out the normal value, it's quite good because y is 700, okay, it's a big number, is 809, and add that together I get 880. So again, he has this energy relationship with cycloid. Let's move on. Okay, now we're going to look at the triangle. There might be a few other bits and pieces, we'll come back to that later. So we're going to look at the Pascal's triangle. Now Pascal's triangle, I shall show you now, very simple. Basically a pyramid. You start at the top with a 1, then you put another 1 and a 1 by its side. And then to get the next line, you put a 1 at the side, and then you add these two together, and that gives you 2. And then you have a 1 at the side. And you keep going down, and you always add 2 above. So 1 and 2 is 3, 2 and 1 is 3, and that comes 1. 1 again, 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, and 1 again. And you keep going down, and you eventually have no more room on your paper to do any more. So that's Pascal's triangle, and they are, what was recognised about that triangle was that they are the coefficients of binomial expansion. Again, this might be completely new to many of you, but GCC mathematics pupils will, whoops, I don't want that, I want an X, will multiply out brackets to find out their expansion. So if I'm expanding those brackets, if you don't understand this, don't worry, we'll skip this bit. Right, you multiply them out, everything gets multiplied by everything in one bracket to the other. So I get x times x is x squared, and I get x times 1, which is just 1x, and I get 1 times x, I get another 1x, and I get 1 times 1, which is just 1. So if I put those all together, I just get 1x squared plus 2x plus 1. And the numbers 1, 2, 1 are the coefficients in the third row of our Pascal's triangle. And if I were to have 3 brackets, and I was to multiply that out, then you would get this. You would get x cubed, 1x cubed, plus 3x squared plus 3x plus 1. Again, you've got 1, 3, 3, 1. And that just gives you the coefficients of those expansions. So we'll leave that out. But the words binomial expansion will come to in a minute. And we'll see how that's connected to Pascal as well. So, looking at his name now, I'm going to actually rub off most of this. I'm just going to leave the top 3 because, as you can see in the top 3, there are 6 numbers and there are 6 letters. So we're going to look at the name. We're going to look at Pascal's name written as a triangle. That's P-A-S, Pascal. Now, you can't get to the bottom without starting from the top. This is the source. This is the beginning. This is one God. The beginning, the one, the source. So, whatever comes afterwards is stemming from the main root. So, we can show you a few interesting things here. If I was to write out Carl, first of all, P is 16, and L is 12, A is 1, and C is 3, and I get 16. So I've got a connection between the P, which gives the root, the source of the bottom line. Whatever the bottom line you're dealing with, it's got its origins in the beginning. So we've got a connection now with P and Cal. So if I was to use now the other values of Cal, so I've got Cal here, I'm going to write it over here, Cal. And we know that the placement value is 16. We've got the large value is 177. The normal value is 34. That's 30 plus 1 and 3. And the normal inner value is 190. So we're going to use 3 of these. We're going to use that one, and that one. These are the large value. Okay? So the placement value and the normal value gives you the total value. So the total value, we're going to add that to the NIV value. That's going to give me 16 and 34 is 50, and 190 is 240. That's the total normal value, or normal inner value of Cal. If I write out base of the triangle, I'm writing at a wrong angle here, base of the triangle of Pascal. Base of the triangle of Pascal, which is that one, Cal, equals, in placement value, 240. So I've got a relationship between Cal, which is the base of the triangle of Pascal, this is the triangle of Pascal, as being 240 in the TNIV value, and that is the same as the placement value of the base of the triangle of Pascal, 240. Thought that was quite neat. So we're going to look now at Blaise, his other name, which is also 6 letters. So again, we'll rub this off. And we're going to put Blaise. B-L-A-I-S-E. So we're going to start with the base. The base is based on the beginning. So the base is ISE. And we have a placement value of 33. That's 9, 19 and 5. 19 and 9 is 28, 33. LV value, the large value, is 170. We have the normal value, which is 114, and we have the normal inner value of 192. So, firstly, we've got the triangle of Pascal. Placement value 192. So we have a relationship now, the triangle of Pascal related to 192, the normal inner value of ISO. Then we have a connection with the words binomial coefficient. CIENT, and that has a placement value of 170. So remember the binomial coefficients 1, 2, 3 or 1, 3, 3, 1, they are the binomial coefficients, but this gives each one of these as a coefficient of the binomial expansion of those brackets. Now, we had before the connection between the top and the bottom of the Pascal, that was the P and the Cal. can we do that with this one? So we take the B. This is a bit more complicated. We take the B, that's the top, and it's a sort of I've done this a few times. It's a sort of a ladder. You take B as 2, that's the placement value. Its large value is 58 because 2, the word 2, is 58. Okay, and then you work out what 58 is. 58 equals. I'm not going to put a line. I'm going to put a sort of an arrow. It'd be better. The word 50, the word 58 in words equal 150. Like the word 2 is 58, so the word 58 is 115. And the words 115 is 192. And now that I've rubbed it all off, but the, well, here, so we've got this one here. The inner, was the NIV value of ISE was 192, and we've got a connection between B now and the normal inner value of that as well. So I'm not sure there's any significance of the number of sort of rungs we had to go 1, 2, 3, 4, 5. We had to go down to get there, but I don't know. But so we have a connection now with the first letter and the base. So the 3 letters have got just a little bit more here on the BLA, BLA. We've got an interesting connection here. If I go through what these are, BLA, and I work out the placement value, I don't need all these, but I'll write them down. Placement value is 15. The large value is 179. The normal value is 33. Now, remember, the normal value of this, no, it wasn't 33, it was the placement value. That was 19 plus 9 was 28 plus 5 was 33. In other words, BLA has the normal value of 33, which equals the placement value of the base. And the final one, the NIV, has a normal inner value of 129. Okay, which is again connected to this, because the normal inner value of this was 192. So both BLA, the first 3 letters of his name, of Blaze, is 192, and the last 3 letters 192 in both the same systems, the normal inner value. So they equate. And I think this is the last bit. Not quite. Okay. Pascal's triangle. Pascal's triangle. One last one on that. So Pascal's triangle that has a whole value, that's the placement value and the large value, of 1,190. That's the whole value. That's taking the placement value and the large value. Pascal's triangle, 1,190. A triangle, which is what it is also, for this I have to use the large value, which is 588, and I have to use the normal inner value, which is 602, and I get 1,190, and that is a triangle. That's what it is, a triangle. So he invented something called an arithmetic machine, or what we might call a calculator, but it was a mechanical calculator. And it was called a Pascaline, or Pascaline. And we're going to show the relationship between that invention of his and his name. Let's see if I can write it here. Pascaline. It is Pascal line. Now that word, Pascaline, has a placement value of 80, and it has a normal value of 269. And if I add that, I get 349. That's a Pascal line. If I go to Blaze, I've actually had this one before. Blaze has a large value of 349. Large value. Okay, so I've now got a connection between, this is what we call the total, what I call the total value, placement value and normal value. So the total value of Pascal line is the same as the large value of Blaze. So it's connected in many ways to what he does, what he invented, what he discovered. They are all connected. Just the last one I've got here is how calculator helps you do arithmetic. Calculator, it's not particularly to do with Pascal, but calculator has a placement value of 106, and arithmetic has a placement value of 106. There we are. That's why we use a calculator. I'm just going to quickly look at what I've written down, because what I've got here are my printed up pages of my book, but I think there might have been one or two other things. I think I've covered everything. Binomial coefficient, we did that, 170. Yep. So yes, I've covered everything there. I thought I'd just add, I've got something here which I just add on as an end, because there's many ways of showing connection between people's names. I've got an entry on Nobel in my book. There's just an interesting thing, because he was into dynamite. I've got connections between his name and what his scientific discoveries. But what is interesting is his connection between what came later. He felt guilty about what he had been raising all his money from, what he made, probably a multimillionaire in those days, what he made in terms of creating war machines, things that will blow people up. So he donated a lot of his money and bequeathed it to the Nobel Prize. So, just to show you a connection with his name and Nobel and Prize, we've got Nobel, and that has a placement value PV of 48, and it has a large value of 356. Added together, I get 404. And I take the word prize, and that's got a normal inner value of 404. So, and one other thing, a Nobel, put a capital M in, respect, Nobel Prize. A Nobel Prize is 123. Saying too quick. 123. Highest award. Highest award is 123. So that brings us to the close. Again, we're using different permutations of the four main gematria systems that I've introduced you to, and it's the placement value is not mine. I take no credit for that. That's been around for a while. A large value I discovered, I have not seen anybody use it, I discovered that going back to 2001, 2002. And I borrowed the normal value from Greek and Hebrew, and the normal inner value again is my invention of using just expanding outwards, just like I did with the large values. And we're using those four values. For quite a few years I didn't have this one. I didn't discover the normal inner value. That was for quite a few years. I've been, this is 16 years, 17 years doing this. I can't remember when I discovered that, but my later books started bringing this in, and it really gave me the ability to show many, many more connections. Of course, again, we've still got to discuss this idea of probability and whether this makes it just, it just bound to work out because you've got so many different systems and so many different permutations of those systems. Isn't it bound to work? The answer is no, it's not bound to work out at all. There are so many numbers. The range of numbers is quite big. It can be a few thousand. So you're talking about a select number of numbers matching a select number of numbers. So it's not so easy. That I'll have to do a bit later. I've got a section at the end of my book on Beyond Science where I show the probabilities of making connections. And it's very, very, very small, considering that if you don't fail in finding a connection, then that just multiplies. In probability theory, you multiply your probability. So if I toss a dice and it's 1 in 2 chance of getting a 1 in 6 chance in getting a 6. If I want to toss a dice and get 6, 6, 6, 6, 6, let's say 10 times in a row, then it will be 1/6 times 1/6 times 1/6, 10 times, and it's very small. So if I've got 200 scientists, which I found connection between their name, even if the probability was a half, it will be a half times a half times a half times a half, 200 times. It's minute. My general probability that I've estimated it's about a third that you'll get a connection, depending on average, depending on how many names you got, how many parts of your name. You've got 2 names. Some have got 3, some have got 4, so it's more likely to find a connection. But the average is about the average number of names is actually about 3 names. So there'd be a probability of about a third, and that when you multiply a third 200 times, it's tiny. So, okay, that's where we're going to leave it off. We've got more topics to talk about, so I haven't decided what the next subject will be as of yet. So I wish you all the best until I see you next time, or you see me next time, and hopefully you'll share these videos with your friends. Thank you.